Now we're going to talk about lenses. And there are two main types of lenses. There are converging lenses and there are diverging lenses. A converging lens, if you have light coming in like this, it comes in, if you imagine it's coming in from very far away and it's all parallel. The light is then all going to go to this one um, point we call the focal point. So these are converging here at this focal point. A diverging lens, if you look at the light, it all comes through and then it starts to diverge or spread apart. But if you were to trace it backwards, it all appears to go, if you draw a straight line back this way, it all appears to come from a place back here. That also is the focal point. So both diverging and converging lenses have a focal point. The difference between the two is that for a converging lens, light goes through the focal point, and for a diverging lens, light appears to be coming away from the focal point. The equations for lenses are pretty simple. Let's take a converging lens. All right, we're going to define everything here. DO is the distance from the middle of the lens to the object. So in this case, the object is this woman over here. So DO, distance from the lens to the object. DI is the distance from the lens to the image. F is the focal length, which is the distance from the lens to the focal point. And if you look at this in terms of the height of the image over the height of the object is minus the distance to the image over the distance to the object is called the magnification. Now, why is this negative sign here? Well, if you look at a converging lens and you use a converging lens, like in a classroom, your projectors use a converging lens to project onto the board. Um, this image is upside down from the object. And so the magnification, M, is negative simply because it's flipping it upside down. All right, so height of the image over height of the object. Well, here the height of the image is negative. All right, height of the image is negative. Distance of the image over distance of the object. Distance of the image is positive. The distance of the image is positive because it's in the direction the light is flowing. So that's positive direction. And then the magnification is minus di over do. This equation, very straightforward and simple. For diverging lenses, the equations are exactly the same, but the meaning of some of these things are different. For a diverging lens, the distance to the image, if it is always going to be negative. All right, it's always going to be negative because images, you don't project through a diverging lens. You look backwards through a diverging lens to see an image. And the image in a diverging lens is always what we call virtual. You can also get virtual images with converging lenses if either the observer or if you are if you're within the focal length. So if you take the object and move it inside the focal length, now you have uh, a virtual image. And what you do is you look through the lens at the object on the other side. And the other side on the other side now is not negative, it's now positive magnification. This is what we use for magnifying glasses all the time. You need to get close enough to the object with the magnifying glass so you've got positive magnification. I'll go over this again in a chart that's in the next slide in the next video.